We use graphs to represent connected objects, such as the routers in a network or people on a social media platform. Using a graph, we can see how people are connected and how strong these connections are. Just like trees, graphs consist of nodes and edges. In fact, mathematically speaking, a tree is a kind of a graph. It's a graph without any cycles. Also, here we don't have a root node. So here we have a graph with 4 nodes and 6 edges or lines. These nodes are also called vertices, which is the plural of vertex. Vertex is an older term. So these nodes can be connected to any other nodes. We don't have a limitation in terms of how many connections or edges we can have from one node. If 2 nodes are directly connected, we say they're adjacent or neighbors. So here John and Bob are adjacent or neighbors, but John and Sam aren't because they're not directly connected. If these edges have a direction, we say we have a directed graph. So in this graph, John is connected to Bob, but the opposite is not true. This is similar to how Twitter works. If you follow someone, there is a connection from your account to their account, but not the other way around unless they follow you as well. Undirected graphs are like Facebook and LinkedIn. If you add someone as a friend, there will be a line or a connection between the two of you, and this connection doesn't have a direction. Now, these edges can also have a weight. We use these weights to represent how strong a connection is. For example, on a social media platform, if 2 people interact a lot, we can put a higher weight on their connection. Later, we can show they're best friends by finding the neighboring nodes with the highest weights. Another application of graphs is in finding the shortest path between 2 nodes. For example, we can use a graph to represent how different cities or areas are connected. The weights we put on these edges can represent the distance, traveling cost, or traffic conditions. Later in this section, I will show you how to implement an algorithm to find the shortest path between 2 nodes. It's very interesting. So this is the basics of graphs. Next, we're going to talk about various ways to implement a graph.